Okay, in this video I want to do a volume of revolution problem using disks and washers. And so the problem we're going to do here, so I've already got a little bit set up. We're going to do the region bounded by y equals x cubed, y equals x, and we're going to rotate that, in this case, just about the x-axis. Okay, so we'll go about the good old x-axis here. And you know, the line y equals x, there that is. Y equals x cubed, I just drew the portion, and I should specify here because I want the portion that's just in the first quadrant. So I should even say x is greater than or equal to 0. So that'll just give us the part in the first quadrant. And the formula we're going to use here, the way I like to think about it is it's pi times the outer radius squared minus pi times the inner radius squared. So I'm going to do some variations on this one in some other videos as well. And the way I think about the outer radius, the way I think about that is whatever line I'm rotating about, I draw a line perpendicular to that. It's going to go through my region, and then just right before it's about to exit the region. That's what I call the outer radius. Okay, so basically I have to think if I'm at some generic x-coordinate, what is the length of that generic x-coordinate? And that's what I'm going to fill in into my formula. Okay, so we'll figure out the limits of integration here in just a second. You might be able to even just guess them here. So it says the outer radius, if I'm at some random x-coordinate, well, the length of this arrow would come from the y value, which is just coming from the function. So the outer radius would be just x squared minus pi times the inner radius. Well, again, I do the same thing. I start at the line I'm rotating about, and I draw it until it just touches the region. And then, in this case, I think, well, what curve is it hitting? The curve that it's hitting in this case is x cubed. But again, I have to square that. We're integrating this with respect to x, so that means the limits of integration are going to come from the x-axis. Well, the smallest x-coordinate that we're using here is 0. Well, to get the largest one, in general, you have to set these things equal to each other and then solve. I mean, you can guess probably the value. But again, just a little bit of algebra refresher. Set them equal, then make one side 0. We could factor out an x. We would get x squared minus 1. If you factor x squared